Hello. Over the next few minutes I'm going to introduce you to the first complete series of digitally controlled board-mounted power converters to be available within the power conversion industry. We've designed these converters for enhanced performance, energy management and end-user value, and so we call them the 3E family. The 3E family represents a groundbreaking power solution that adds an unprecedented level of flexibility that will improve systems performance. And since we're all concerned about saving energy, an efficient and flexible power solution is a must, and it begins with Ericsson 3E. Conventional intermediate bus architectures are based on an isolated DC-DC converter stepping down a distribution system voltage to an intermediate voltage that typically varies from application to application, say from about 3.3 volts to 12 volts. The intermediate bus voltage then powers a range of analog point-of-load voltage regulators that step down the intermediate bus voltage to the specific voltages that the load circuits require. In such a setup, the point-of-load regulators use analog control chips and supporting passive circuitry that establish basic operational parameters such as efficiency, voltage settings and possibly voltage sequencing. These settings are almost inevitably limited to intrinsic product performances, original factory adjustments or board settings. Moving from analog to digital introduces a new dimension: flexibility. This flexibility makes it possible to create system architectures that can be fully monitored and controlled. Let's have a look at the products themselves. The 3E family allows you to build systems that offer unprecedented flexibility together with best-in-class performance and yet are extremely easy to develop. 3E DC-DC converters have conversion efficiencies of better than 96% over the great majority of their output ranges, as the cores can adapt themselves to changing line and load conditions in real time. This results in much better energy efficiency than previous generation analog converters can achieve. Furthermore, component numbers are reduced as the digital cores significantly improve integration and can even pack an entire PM bus measurement and control interface alongside the core control logic. The most powerful device in the 3E family is a 400-watt quarter-brick intermediate bus converter that transforms 48-volt backplane power to a level that suits the point-of-load converters. It is complemented by an 8th brick version that's capable of 240 watts. These isolated output converters downconvert distribution bus levels within the normal 36 to 75 VDC to levels that suit the 3E point-of-load regulators, which have an exceptionally wide output adjustment range from as low as 0.6 volts up to 5.5 volts. Each of these converters can easily replace and upgrade former devices with no additional effort on the designer's part. Let me show you how easy it is to set parameters on the fly. When you start the GUI, you will see a screen similar to this one. On the left is a list of devices connected to the PM bus. The device status is shown. Green is on, red is off. On the right, we have 3 windows. The System Overview tab shows the connected devices and real-time monitoring values. The Device Monitor tab shows these values as graphs for the selected device. The red and blue lines are warning and fault settings. We can see this device is set to 1.2 volts output. I'll change that to 1.0 volts. The middle tab is the device configuration menu. I change the value, save it, and on the device monitor screen we can see the output voltage has dropped from 1.2 to 1.0 volts. Simple as that appears, the 3E GUI will let you do much more than adjusting output voltage. Among its many features, you will be able to adjust many other parameters such as current limitation, alarms threshold, sequencing and ramp-up time, giving you full control of strategic parameters that result in a highly optimized and efficient configuration that reduces energy consumption. Whilst any of the 3E converters can upgrade former analog converter designs with no extra effort, most users want to explore the programmable aspects of these new devices. Ericsson's 3E evaluation kit provides the board, the DC-DC converter and point-of-load converters along with a PM bus to USB interface. And as we've just seen, the application software lets you communicate with the power conversion system via an easy-to-use graphical user interface. You only need supply a PC and basic lab instruments to get up and running within minutes of opening the box. Much more information, including comprehensive technical articles, is available at Ericsson's website. Please be sure to visit and see what's on offer.